Hello everyone. Today we are going to learn how to solve scheduling algorithm problem based on round robin algorithm. Okay, so now we have to see how to solve that problem. Okay, at 0 arrival time, P1 will send request to the CPU. So P1 will enter into the CPU queue. So the P1 will start to execute first. It will continue till 0 to 3 minutes. Okay, it will continue from first 0 to 3 minutes. After 3 minutes, task P2, P3 and P4 that will be ready to run, and it will send request to the CPU. So now P2, P3, P4 they are in a running state, but in that P1 will come at the first microsecond. That's why P2 will enter into the request queue first. At P3 time, at 2 time P3 will occur. That's why it will enter into the request queue, and at 3rd microsecond 4 will enter. That's why P4 will enter into the CPU queue. Now the quantum is given to each and every process respectively. That's why the next quantum is given to the P2, because P1 is already processed. Okay, but in case of P1 its burst time is 10 and only 3 microsecond time is given to that task. That's why it is pending. So its remaining time is 10 minus 3 is equal to 7. So it is not completed. That's why it will send request once again to the CPU. That's why it will enter into the queue. Okay, now from the next 3 microsecond P2 will continue. After this third quantum, P2 will stop. Okay, and the next quantum is given to the next queue, next task, that is next process, that is the P3. So the CPU command is given to the task P3, but in case of P2 its burst time is 4 and only quantum of 3 is given, 3 microsecond is given to it. That's why it is in pending condition. So it required only 1 microsecond CPU time for the execution. So it will once again send request to the CPU. So P2 will enter into the request queue. Now P3 will process for the next 3 microsecond quantum. After P3 there is P4. That's why P4 will get CPU access. But what about P3? Its total burst time is 5 and only 3 microsecond timing is given to its. That's why its pending time is 2 microseconds. So it once again P3 also send request to the CPU. Okay, then P4 will process for the 3 microsecond. After P4, then in the queue there is P1 is present. That's why quantum is once again given to the P4. But what about P4? Its burst time is 3. That's why, and 3 microsecond timing is given to P4. That's why P4 will complete it. So its burst time will be 0. Its pending burst time will be 0. So after P4, P1 will process for the 3 microsecond. Now pending time of the P1 was 7 and it is now processed for the 3 microseconds. So its pending time is 4. After P1, P2 is there in the request queue. Okay, so P2 will be processed. But what about P1? Its pending time is 4. It is still not completed. That's why it will send request and it will enter into the request queue. Then P2 will be processed for the next 3 microsecond. After P2, P3 is there. That's why P3 will start to process. But what about P2? Its pending time is 1. So it will not process for the 3 microsecond. P2 will process only for the 1 microsecond. P2 will be processed only for the 1 microsecond. So after that 1 microsecond, P3 will start to execute. What timing P2 will require? It required only 2 microsecond. That's why it will continue till 2 microsecond. After 2 microsecond, then task is given to the P1 or CPU access is given to the P1. So P1 will start. Then P1 will start. So 3 microsecond. Its pending time is 4. So 3 microsecond timing is given to the P1. So its pending time will be P4 minus 3. It is equal to 1. So still it is not completed. So once again P1 will send request to the CPU. Okay, so after P1 is there, so it will be processed once again, but now it is only 1 microsecond it required. So that quantum will not continue 3 microsecond, it will continue only for the 1 microsecond. In this way that process will be executed. So Gantt chart will give the proper execution sequence. So depending on that we have to calculate the total turnaround time and total waiting time. So my second question is, if the time quantum ends but the burst time is not completed, then that means here burst time, pending burst time of CPU was P1 was 7, and here only the quantum is 3 microseconds. So what happened? So the answer on that is, if the burst time is pending, then that task will enter into the request queue once again. Okay, so we have to calculate now total turnaround time and total waiting time. So next is we have to calculate the completion time. So this is our chart. Then depending on that, we have to calculate the completion time. So first task which is completed, that was the P4, and it is completed at the time 12. That's why its completion time is P4 completion time is 12. Now what about P1? P1 is completed at the completion time at the time 22 microsecond. Now P2 is completed where P2 is completed at the 16 microsecond, and P3 is completed at 18 microsecond. So by using that Gantt chart, we can calculate the completion time, that is 22, 16, 18 and 12. Now turnaround time and waiting time we have to calculate. So formula for calculate the calculation of turnaround time is completion time minus arrival time. So by using that chart, 22 minus 0, that is 22, we can calculate these values. And waiting time is individual waiting time of the process is turnaround time minus burst time. So turnaround time we have, and we have the burst time also. By using this two columns, we can calculate these values, that is 22 minus 10 is equal to 12, 15 minus 4 is equal to 11, 16 minus 5 is equal to 11, and 9 minus 3 is equal to 6. Now my next question is, take a moment. If we have the 4 individual turnaround time for the processes and 4 individual waiting time for the processes, how will you calculate the average turnaround time and average waiting time? Calculate your answer and write down on your notebook. So the answer is, we have to calculate addition of all turnaround time of individual process, and we have to divide them by the total number of process. So here we can calculate total turnaround time is equal to 54 millisecond, and similarly we can calculate the average waiting time. We have the individual waiting time, and that we have to divide it by the total number of process. So here 35.5 microsecond will be my average waiting time, and 54 microsecond will be my average turnaround time. Thank you.